Following on from the previous video, when given a displacement time graph, if you differentiate it, it will give you your velocity time graph. If you differentiate it again, it will give you your acceleration time graph. So you can think of this as being your y, and then when you differentiate this, you can think of this dy by dx as being your velocity. And then if you were to differentiate it again, then it will give you your acceleration. So when given your acceleration time graph, you can in a way find the indefinite integral, and then that will so when given the acceleration time graph, if you find the indefinite integral, then that would then in a way it represents your velocity. If you find the indefinite integral of the velocity time graph, then it will then give you your original y equals whatever over here. And the point of the previous video was that the acceleration time graph doesn't always have to be horizontal. The velocity time graph doesn't always have to be a straight line. It can be something weird like this. And then from when given something weird like this, you can actually work out the acceleration time graph by differentiating it. And then when given something weird like this, you can work out the displacement time graph by finding the indefinite integral in a way. Okay, so for example, hang on. So for example, let's just say dy by dx is given by this things here. So your velocity time graph looks something like this. And by the way, I interchange x and t around, so just bear that in mind. So let's just say the velocity here is given by something weird like this. So from this, you can actually work out your displacement time. Well, you can actually work out the position at any given time. So when given something weird like this, if you want to find your y, remember y in this case represents a displacement. If you want to find the displacement at any given time, what you do is, hang on, you know that when given the displacement time graph, if you differentiate it, it will give you your velocity. When given a velocity time graph, if you differentiate it, it will give you your acceleration time graph. But here's the thing, when given this here, you can find the indefinite integral, and then that will then take you to your y equals blah blah. Okay, so as an example, let's take this now. If we want to find out the y, so when given dy by dx equals this, if we want to find out the y, then it really boils down to you finding the indefinite integral. So so the indefinite integral is given by this, and then we've got to plus our constant. But here we've been given that when time equals 2, the position here is 6. So from this we can actually work out our constant here. So hang on. So we've been given dy by dx. So you can think of it as being, we've been given the velocity as this. Okay, and then if you want to know the actual position, which will be y, if you want to know the actual position, then find the indefinite integral of this. That will then give you this. But then we need our constant. But now using this, we can actually work out our constant. So hang on. So the indefinite integral is given by this here. So we can think of it as being y equals this thing here, because don't forget we've been given this here. So when we find the indefinite integral, it's really us having y equals whatever here. That's what we've got here. We've got y equals whatever here. Okay. So now using this, now we need to find out c. So looking at the initial condition here, when x equals 2, or another way of thinking of when t equals 2, remember I changed the x and t around. Okay. Well, anyway, use this to find out your c. So in this case, x equals 2. When x equals 2, y will be 6. So looking at this here, when x equals 2, y equals 6. So let's put the x, when x equals 2, y will be 6. So put the 2 into here, and then into here, and then don't forget y will be 6. So that's this 6 here, and then blah blah blah. C equals this thing here. So what that means is that we've got c now, so we can put it into. So this here is our c. So now we've actually worked out the displacement at any given time. Okay, I will give you some practice in the next video.